Hello everyone. In this video we are going to learn about different types of registers. In our previous lectures we have seen that what is registers and for what we are using the registers. But based on the use we are using the different types of registers. So we'll see the types of registers and what are the use of that registers. So let's start. So first we'll start with the memory, or we can say that the RAM. When we are when we are executing some task, at that time our data is stored in the memory, that is called the RAM. So suppose let's assume that the size of the memory is 4096 cross 16. So what is the meaning of this? Here 4096 is a number of words that can stored in the memory. Suppose this is a computer's memory. So each block represents one word. This is the first block, this is the second block, this is the third block, this is the fourth block. Yes, so if your memory size is 4096 cross 16, it means that there are 4096 blocks available in the RAM. Okay, so that is the meaning of number of words. Here 4096 cross 16. So what is the meaning of 16? 16 means the word size in bits. It means this is the first word and this first word contains 16 bits. So here you can see that this is the first block and this first block has 16 small different blocks inside it. It means that each block stores the 1 bit and that is total 0 to 15, means there are 16 bits available in one word. In the second word also we can store the 16 bits. In the third word we can store 16 bits and so on. So that is the meaning of 4096 cross 16 size of memory. Suppose the size of the memory is 1024 cross 8. It means that there are 1024 blocks or the 1024 words in the memory, and in each word there are 8 bits. So it is depends on what memory you are using. Okay, so this is the computer's memory. Now how the address of the memory is given. Now as I said that the block size is 4096. So 4096 is equals to 2 raised to 12. So now you can say that, so here 2 raised to 12 means 4096 blocks available. Yes, so we need to address each and every block. So the first address contains, because here 2 raised to 12 means the size of the address is a 12 bit. This needs to be remembered, that if it is 2 raised to 8, it means that if the size of the memory is equals to 2 raised to 8, it means that the size of the address is 8 bit. Here it is a 2 raised to 12, it means the size of the address is 12 bits. So here you can see the value of the first address is 0000 up to 120. Then the second block's address is start with the 0000 and up to 1. Third is 0000 up to 010 and so on. And the last block, and the last block's index value is 4096, and the address of this block is 1111, means all ones. So the first address contains all zeros and the last address contains all ones, and in between there are 4096 addresses available. So this is how the RAM is defined. Each RAM has their particular size. Based on that, the multiple blocks and bits is available and corresponding address is given to the memory. Now the next is a address register or the memory address register. So it is mostly a 12-bit register used to store or holds the address of memory. This register holds the memory addresses of data and instructions. Here you can see that each and every data contains some specific address. Suppose this is a computer's memory. In that some value is stored. Suppose the value is something like 1110 1111 000 110 001. So this is the data, actual data that is converted into the binary numbers, and then it is stored into the memory. So this is a data. We can fetch this data by using some particular address of the memory that is given. So here the address is all 12 zeros. So that is the address. So here address, the work of the address register is, the address registers holds the memory address of the data and instructions. So here our data is stored at this particular address. So the work of the address register means in the address register only the addresses of the data is stored. Suppose we are storing some instruction here, so it also has some address. So this address value is stored at the address register. So we can say that the purpose of address register is just to hold the addresses of the data that is stored into the memory. The register is used to access the data and instructions from memory during the execution phase of an instruction. Suppose instruction is executed, so at that time we require a data from the memory. So processor finds the address from the address register and then fetches the data by using that address. So we need that data, so from address register we'll fetch this address, and from this address we'll fetch this data. Suppose CPU wants to store some data in the memory or to read the data from memory. So it places the address of the required memory location in the address register. Yes. So basically it is a 12-bit address. Here we can see that in this example, because generally the memory size is 4096 cross 16, it may be vary. Yes. So that is why we can say that generally it is a 12-bit. So as I said that here the size of the address is 12 bits. So that is why we can say that it is mostly a 12-bit register. Suppose in case memory is varying, at that time the address register's value also vary. Now next is a data register or a memory data register. Our data is stored in this memory. Yes, and as I said that the one word contains 16 bits. So here as I said that this is a data value, and this data value has a 16 bits. This is the first bit, second bit, third bit, fourth bit up to 16. So it has a 16 bit. So here we can say that the data register is mostly a 16-bit register because it holds the 16 bits of data. It contains data written into or to be read out from the address location. Now I want to read some data that is stored onto the memory. At that time we are using first address register. From the address register we are fetching the addresses, and from that corresponding address we are fetching the data. After fetching the data, we need to store the data at some particular location, and that particular location is a data register. So data register is generally used to store the data. So MDR is the register of the computer's control unit that contains the data to be stored in the computer storage or the data after a fetch from the computer storage. It acts like a buffer and holds anything that is copied from memory ready for the processor to use it. And suppose I want this data and I want to add 12 into this data. So first we need to temporarily fetch this data and store onto the data register, and then we'll process the arithmetic operation on it. Now next is the accumulator register. It is mostly a 16-bit register, also known as a processor register, which is usually located inside arithmetic logic unit and is used to store results of arithmetic and logic operations, and is mainly used for storing the operand and used to hold data for this purpose for a short period of time or the short time. Now we can say that it is used to store the intermediate data. Suppose I want to add the data of two registers. Here A and B are the two registers, and I want to perform the addition operation on it. So at that time we are using the data register A, data register B, and will perform arithmetic operation. After that the result is stored into the accumulator register. After adding this data of these two registers, we are not directly storing this data, this value, to the memory, but first we are storing onto the accumulator, and then after the data is stored or updated onto the memory. So it is an intermediate. Mostly when we want to perform the arithmetic or the logic unit, means I want to perform some micro operations, at that time at intermediate location we are using the accumulator, and the size of the accumulator is a 16-bit. How? Because we are storing the data that is stored onto the data register, and the size of data is 16-bit. That's why the size of the accumulator is also a 16-bit. Next is a program counter. So it is mostly a 12-bit register, also known as the instruction pointer register. It keeps tracks of the next memory address of the instruction that is to be executed once the execution of the current instruction is completed. So what it means? So in this memory, suppose instruction is stored here, the second instruction is stored here, the third instruction is stored here. It has some memory address here. Suppose this is a program counter and that is pointed here. After execution of this instruction, this block becomes empty. So at that time the program counter does not point here, but it points the immediate next address. Now here the second instruction is there. So now the program counter point this instruction. After execution of this, the program counter points this instruction, and so on. So suppose the address of this is 1. So then after execution of this instruction, it pointed to the next address 2, and then next address 3, and so on. So this is how the program counter keep tracks of the next memory address of the instruction. In other words, it holds the address of the memory location of the next instruction when the current instruction is executed by the microprocessor. Okay, and the size of this is a 12-bit. How? Because program counter is pointing to the address, and the value and the size of the address is a 12 bits. That's why the size of the program counter is also a 12-bit. Now next is the instruction register. So it is mostly a 16-bit register used to hold the instruction code of an instruction fetched from main memory for further decoding or for executing it by help of control unit. The IR holds the instruction which is just about to be executed. Now suppose this is a memory. Memory has a different types of data in it. Suppose I want to store data. At that time I am using the data register. But suppose there is one instruction 0 add 2. So this is the instruction. This instruction is also stored at the memory location. So when I want to fetch this instruction or when I want to execute this instruction, first I need to take this instruction and put it onto the instruction register. Yes, so the purpose of the instruction register is just to hold the instruction that needs to be executed. So the instruction register holds the instruction which is just about to be executed, and the size of the instruction register is a 16-bit. How? Because here the size of each word is a 16-bit and the instruction is also stored at the memory. So the size of the instruction bit also become the 16-bit. Next is the input register and the output registers. Suppose I am giving input. Suppose I am writing onto the computer's memory. At that time I am providing the input from my keyboard. So that is stored into the input register, and then after it is permanently stored onto the memory. It does not directly stored onto the computer's main memory. So it is a mostly 8-bit register used to hold or store input data from any of peripheral or entered input devices. Here 8-bit is not fixed, it depends on your input devices. Mostly the input devices are the 8-bit, so that is why here I am writing the 8-bit, it is mostly 8-bit register, but it depends on your input devices. If your input device can provide a 16 bits of data, at that time the size of the register is a 16-bit. Next is the output register. So it is mostly a 8-bit register used to hold or store the output data to show the output on one of the following devices after performing various operations by CPU on input data. So when I want to read data from the memory, so first it's fetched and then stored onto the output register, and then the data of the output register is displayed on the computer's or any device screen. So at that time It is also depends on the device, but generally it is a 8-bit. That is why the size of the register is also 8-bit. So that is all about the different types of registers that we are using for this specific purpose. We are not using the same register for the all purpose. If we are dealing with the instruction, at that time we are using the instruction register. If I am giving the input from my computer, at that time I am using the input register. Suppose I am performing some arithmetic operation, at that time the output data first stored onto the accumulator, and so on. So each and every register has a specific use. So that's it. Thank you so much.